Number 2 was composition. Number 10. Were you paranoid until you went too far? There was absolutely no simplifying that could be done, could be done, could be done, could be done, or could be done. How many kittens got killed in the making of number 10? Do you know how a kitten gets killed? If you look at something like a polynomial over a polynomial and you don't think about the factors, you just think about the terms and you say, yay, x squared, ha ha! How many of you guys did that here? Did anybody try to cancel any of these out at all?
I thought about it, but then I was
Did
like,
anybody try to cancel any of those out? If so, you're wrong. All of those were illegal. All of those were illegal.
Yeah, I wanted to, but
Some of you just couldn't say no. You just couldn't stop. You had to keep going. There was one legal thing you could have done. You could have put him over 1 and gotten a common denominator. So if you legally simplified, you could have gotten, what would that even look like? That would be x squared plus 1 times the square root of x squared minus 4 all over x squared minus 4 and a square. Nope, sorry, wrong denominator. All over x squared plus 1. You could have done that, but I doubt anybody did. So if you tried to put it together any other way, you were wrong. This one, they did put it together. They put him over 1 and multiply the top and the bottom, but that is absolutely all you could have done. If you tried to take this square root and say, haha, that's x minus 2, you're wrong. Poor little puppy just died. You have to factor him. He's an x plus 2 times an x minus 2. That's not a perfect square. Nope, 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 nope. Don't kill kittens, don't kill puppies. I don't think Steels could have really died in this one. This one in division, you would have had to multiply by the reciprocal, make him over 1, and then just mush them together. But that's about all you could do. Unless you really wanted to distribute that square root to write it 2 times, but otherwise, I would have just stopped. So what some of you forgot is that these are grouped. Numerators and denominators are grouped, and without factoring, you can't take them apart. Yeah?
Go to the bathroom.
Yes, you may. Don't get lost. Keep your phone on your desk. Domain was just, domain was nasty. Domain was a little bit rough. Because if you looked at letter D, the whole reason they're asking domain, guys, is because there's a denominator, right? And so denominator, yay, x can't be 0. Done. Except for what else was there?
Complicated.
What's the issue with square roots?
Can't be.
They can't be negative. They meaning whatever the argument is, right? Now, this is a little bit rough. We're not going to review those types of inequalities until the end of chapter 2, I think. So long story short, we just need this quantity to stay bigger than 4. We need that quantity to stay bigger than 4, and the way to do that is we need whatever is in there, positive or negative, to be greater than 2. Now, usually it would be greater than or equal to 2. So whether you have a 3 or a negative 3, a 4 or a negative 4, or even a 2 or a negative 2, it will be greater than or equal to 0. But why is the domain so awkward? Wait. Oh, just kidding. He's fine. Sorry, I thought they took away the not equal to. What happened to him?
Non-existent.
So why didn't they write him? Isn't that a problem? Or did you think about the number line? Where's 0? If we're only allowed to have these numbers and these numbers, will he even be? He's not possible. He's not greater than 2, so forget him. So yes, that's true, but it wasn't needed. If we did the square root thing, he wasn't even included. Yeah, I guess that's fine. Okay, number 18. You guys legally simplified, right? You FOILed them and combined like terms and got t squared minus 3t minus 1. Minus 1. Are you killing things? Please don't. Ah, but why were you confused? Because your brain sees this and wants to think times. Yeah, but how do you do up? I would rewrite it first. There was someone in here doing this after school yesterday. Rewrite it first. Life gets so much easier. Then FOIL it and combine it and then write it. Yeah. It just looks weird, right? It doesn't look normal. Composition, how'd you do? My ones that are playing games, remember, I don't tend to be mind as long as you're getting everything right, Nathan. Are you sure that you're grading? If you're getting everything right, it's good. I just want to make sure that you're grading. I should have said playing games and talking, because both categories I was concerned. Was this one a little bit weird? Because it was G of G, you were plugging him into himself. Let's look back and people like looking at fingers. What do you know? 42. How the plugging in go? Remember, you're not going to see it real well here. Look back and see how it was plugged in, and then check to see if you simplified it right. Look back to see how it was plugged in, and then check to see if you, whoa, letter B. This is one of those places where it kind of looks like magical math happened. Or I should say magic happened, but it was actually math. What would have been hard for some people to see would have been this jump right here. Can anyone tell me what happened between here and here? The grader did mental math. It's getting a common denominator. Do you guys see it? That guy has a denominator, this guy doesn't, so they multiply top and bottom by x squared minus 1 and then combine 3 plus x squared minus 1 all over. So this was a common denominator. But this is one of the examples, guys, when you're doing Calc Chat. Most of you, your brain doesn't do this. So I shouldn't see your work doing this. Does that make sense? So if I put a comment in your homework when I take more time over the weekend and look at your Google Classroom homeworks, if I say something like magical Calc Chat jump, question mark, do you know what I'm going to be talking about?
Yes.
That your work is doing magical Calc Chat jumps that I don't totally believe your brain thinks? Now, if you can come in and be like, give me anything, I got this, then okay, cool. I'll take away the comment, I'll give back the points. But let's not be making magical jumps that we don't understand. Let's be putting question marks and bringing them to class, yeah? Okay. 44, you might have gotten confused. You knew it was of and not times, right? 52. Okay, this one was weird. True? What was the one thing that we did not talk about yesterday? These guys. Okay, let's pause real quick. We're going to come back to homework. No, let's do homework questions all the way up until the decomposing. I think, wasn't the directions, weren't they decomposing or decomposition or something about? Yeah. Perfect, perfect, perfect. Let's not do those questions, but any other questions? Emma? 23, got it. Anything else besides 23?
Oh wait.
Maybe 44.
44, got it. Anything else?
35.
35? Hold on, now I'm losing track. 23, 35, 44, and then we have the decomposing. Decomp. Bloop, bloop. Anything else? Got him. All right, number 25. Oh, 23. 23 first. He is a nasty, can you figure out who he is? Question. So we have x squared plus 1 and x minus 4. X squared plus 1 and x minus 4. Man, just walking I lost it. I'm getting old. X squared minus 4? And then x minus 4. Got it. Here's what I would have done, just because it's easier on my brain. I would have rewritten. And then I would have come up here and found everybody. So it would have been like, who is f of -1? That would be -1 squared plus 4. I mean, I probably would have done mental math, sorry, but yeah, there you go. And then we have g of -1. Ah. Whew. You guys do positives and negatives? You know that's -2 and not 0, right? Right. I'm not judging if you thought it was 0. I'm just understanding we're still having issues with positives and negatives. Some of us. And then 3 minus 1 is 2. So I have 5 over -2 minus 2. If you guys jump to the final answer on, I should check this one when I do Google Classroom, number 23. It's too late for you guys to change it unless you unsubmit and put it back. What am I curious? I'm curious if you jumped to the final answer and whether or not you can do it mental math. I'm not saying you couldn't. I'm just curious. Yeah. Because what would you end up with? Is anyone mental mapping it right now, not just looking at the answer?
But on everything else, it said like negative or 3 over 5 or something like that.
Oh, really? On 23?
Yeah.
Ooh, it could have been a calc chat mistake, but double check me. Hold on. I did it right? Is that what you guys got?
It was on calc chat later and those are the book over 5. Because that was checking my answer. I was checking my answer.
Yeah, that's exactly what you're supposed to be doing.
Yeah, everything's like 3 over 5.
Yeah, because you would have done that, then you would have done that over that, and it would have been negative 5 minus 4 is negative 9 over 2. What was the answer they gave? 5 over 7?
3 over 5.
Ew.
To everything.
Okay, so obviously there were issues on CalChat for this. 3 over 5 for everything. That's so funny. And the back.
Everything.
What am I wrong with? Did I write the function wrong? Oh! I don't know. Whoever got 9 over 2, he wrote the functions wrong the way I wrote the functions wrong. It's x squared plus 1 and x minus 4.
Yeah, I was like, what?
Okay, my kiddos that were confused. Why didn't you bring up the confusion before I did the whole thing?
I just thought I was, because I thought it was.
Don't do that. Have some confidence.
Yes.
Did I just rewrite it wrong again? I did, didn't I? Is it 1 and then 4?
Yeah.
Wait, so is it?
Yeah, it's x squared plus 1, x minus 4.
What game did you want?
That day. Well, at least, if you wrote it wrong, you did the math, right? You just got the problem wrong. Okay, so, when we have f of negative 1 and g of negative 1 and g of 3, then we have 2, then we have negative 5, and then we have negative 1, and so then you have 2 over negative 5. Sorry, where's my formula? There it is. Minus negative 1, which is plus 1. Hey, it's easier! My kiddos that are writing the magical jumps from CalChat, you're supposed to be figuring out how to actually prove you can do this if I ever come and confront you. Can you do mental math with this one? Why is it 3/5? Put in your calculator.
5 over 5. 5 over 5 is 5.
You can multiply by 5 over 5 and negative 2 plus 5 is 3. Wow, that lunch is smelling good. We have number 35. Okay, remember the art of the. Remember the art of the. Number 1 and number 2. If you're bored, remember I have games everywhere, all over the place. Okay. Or find cool games to put in your calculator. That's even more fun. So we need to do f of g and g of f. So f of not right this second because you need to hook it into a computer or steal someone else's calculator and a cord to connect. But it would be fun. F of g is my first one. So remember, I have to ask myself, who is f? Well, f is that dude that takes the square root of a quantity plus 4. But what's the quantity in f of g of x? Well, he's still square rooting. He's still adding 4. But who is he adding 4 to and then square rooting? G of x. And so if you take g of x and if you plug him in, that's where you get your x squared plus 4. And we cannot go farther, but someone prove to me your mathematical, what's that word? Oh, I can spell it. Prowess? Yeah, that's what I was looking for. Thank you. Why can't we go farther?
Because I don't want to kill a puppy.
We don't want to kill a puppy. And how would you factor this in a way that you would have a perfect squared binomial? Because to factor it, you need the zeros, and to solve for the zeros, wouldn't you have a square root of a negative number? Ooh, that's rough. They're imaginary. There isn't even any real factors to that, dude. If I go the other direction, I'm asking myself the question, who is G? Because I have to put F in there. G, well, he's the dude that says, give me somebody and I'll square him. Who am I squaring? F. And who Who is F? Ooh, now this is cool. Can I actually do some math? Because a square root squared, what do I get? Square root is a 1/2 power, and a 1/2 power times 2 is a 1 power. They can't split it. Last question, number 44, and then we are going to talk about decompositions. Okay, number 44 is the next page, right?
Yeah.
¿Dónde está? Ooh, I like this question. Now, here's a random comment. Those of you that are bored, I would pay attention right about now. Or distracted. Those of you that are distracted in any way, shape, or form. Tune in. Because I love this problem. But not because of pre-calc. I love this problem because of calculus. And here's why. There are times in the AP guys like to ask a calculus question where they force the student to be able to get the information from a graph, but in a very non-traditional way. Super similar to this. It's a tricky question. It's a really tricky question, but it's a great question for your future, possibly, if you hopefully continue on with me. Okay. Is it okay if I just rewrite it to make it make more sense in my brain? Is that all right? Way easier on my brain. If your brains just think, okay, cool. Mine doesn't. So now I can say, okay, every time I'm looking for an f of or a g of, aren't I looking for a y value, guys? Aren't these y's? And aren't these guys x's? I mean, obviously x, but they're x's inside and you're getting out y's outside. True? Cool. So isn't this f of 1 technically a whole sentence? Isn't it saying, I desire the function value of y when x equals 1? Sure?
Yes.
So I need to go, first of all, figure out who's f. Oh, it's that guy. And then, when x is 1, got it, and then I'm looking for the y. I have to go to the graph of f, locate when x is 1, and then identify the point that goes with it. You see it? So you guys tell me, someone who didn't get it last night, what would g of 1 be? See it? You have to go find g, go find when x is 1, and identify the y. Got him. Hence why the final answer was -1. So now this one's a lot easier because now you're like, oh, I'm in a rhythm. Let's go to 4 on the f graph and find the y. Got it. Let's go to when x is 4 on the g graph. Got it. Dun, 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 dun. Check, 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 decomposition. Check, 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 decomposition. Here we go. Number 52 is your final even. I think you might have had an odd, sorry, an odd. Brace's bread. There we go. Little stuff. So, way back. What was this asking you to do? First of all, what's his name? H. And what did the problem say that you're supposed to be finding H to be?
Find two functions for f.
Wow, you guys do every word. You're awesome. Yeah, find two functions where h is f of g of x, right? So I'm trying to find h such that he's f of g. Think matryoshkas. I showed you that yesterday, right? Russian nesting doll. They want me to state him as a composition. Basically say, okay, yeah, he's one function. Great. But we can look at him as though he's a function in a function.
It's a product of function.
No.
No?
He could be, but they're not asking me to do f times g, they're asking me to do f of g. So if I answer with a product in this context, I'm wrong. But I'll show you how it could have been a product, just that's not what they're asking. So I need an inner and an outer. Why am I going to box this guy? Is he inside anything?
Yes.
Yeah, he is.
He's
He's
inside
inside
an
parentheses.
X-squared, which could
Now
be
sometimes the
X-squared.
inside's under a square root, sometimes the inside's in an ln or a sine or I don't even know what else. But I see an inside, he's right there. So guess what? My g
5x plus 2.
is 5x plus 2. And if my g is 5x plus 2, then my f is going to be anything. Now, be careful. Well, if it makes it a little bit easier, we could do f of g. And we could say, okay, so if I just named this guy g, wouldn't I have g squared with a 5 on top?
4.
With a 4 on top? That's all. But if I want to actually write f of x, which is what they were asking for, I take out the g and I put in an x. My decomposition says, hey, he could have been formed. He could have been an answer to taking this f of g. You see it? So the one little baby piece of notes. Notes. Notes back open. I want you to go to section 1.8 at the end, which is the same thing as right above or before section 1.9. At the very end of 1.8, right before 1.9, what's the one thing we didn't write down? Now, if there is a very select few of you that are like, no, my 1.8 notes went literally down to the bottom line and below, well, squish this in on the side, but for the majority of us, I bet we have a little room under 1.8. This is what we didn't get to take yesterday. Does this make a little more sense now? To decompose. Squish them in, somewhere right there towards the end of 1.8. To decompose. It's a mathematical term. It's for undoing a composite function. Hey, undo, not the context I meant, but it kind of works. Undo is important for 1.9. Good catch. Decompose. We see that. You have some sort of an understanding, right? Decomposing the body. What's it doing? Breaking down. True? Well, it's not a dead body, it's breaking down. But anyway, live bodies can break down too. Decomposing a dead body that breaks down. So what are we doing to our matryoshka? We're breaking them apart. We're breaking them out. Breaking who out? Breaking the little guys that have been trapped the whole time. Hey, let them free. So if we're trying to break everybody out of this example down here, looking at this functions inside out, I think it's easiest. Ooh, he's going to be harder because he's an f of g of h. But I always go for that innermost guy. Not so much with the matryoshka. You have to kind of feel off, right, layer by layer. And these have layers. But with math, I think it's almost easiest to say, okay, who's the innermost? Does anybody see who the innermost would be for this one? X plus 1. See him? He's under a square root and he's in a square. He's like doubly trapped. Oh, doubly trapped. He's inside two functions. Cool. So if I can identify who h is, well, it's a bit of a strategy. I usually go next, to be honest, for f. It's usually easiest to figure out the innermost when it's like a set of 3, and the outermost, because the outermost, man, I just see a big old square root, don't you guys?
Yeah.
So I would say f is a big old square root. The question is, all right, what's in between?
X squared minus 2.
I've dealt with that guy, and I've dealt with that guy. I need a block squared minus 2, and the block squared I have to replace with an x. How would you double check any decomposition? You would compose them and say, well, if we put them all together, does it work? Guess what? It works. Lining up my poor little church. Okay. Look back over those decomposition ones at the end of homework. If you were like totally confused, now at least you have an introduction of it, both the even that we went over and the notes. But now, homework grading is done, at least for right now. If you have other questions, come on in and find me. But we need to get back to starting section 1.9. So everybody on the same page. All distractions, all games now cease. Put a little bracket around it, and then it'd be like a 1.8 beside. Hey guys, remember how section 1.8 I said notation was the trickiest part? Guess what 1.9, well, to some extent, guess what 1.9's trickiest part is also going to be? Which is why I have the note, not the reciprocal, followed by I don't even know how many exclamation points. In last section, it was not times, right? Not times, not times, not times. Instead of times, it was the word f of g of x, or f of x plus g of x. It's not times, it's of. But in this one, it's not reciprocal. Check it. It's inverse. So what am I talking about? My Algebra 1 kids just had a test today. And a lot of them, like all chapter long, anytime they saw this, they were like, -2! And I was like, oh. Even though we have a really cute little rule book, and I was trying to, like, I made little notations and examples for them. And we talked about exponents, and anytime you see a negative exponent, you flip. And if they saw this in some sort of context of like this with this, they knew it was supposed to flip, whether or not they remembered to make that a positive exponent. They knew in this context, but as soon as they saw it like this, on the quiz they took, almost everyone said, oh, -2. Why? Because they wanted it to be that, because it was easier. How do you guys get your exponents? Who is this guy? 1/2, right? You have to write them over 1 and then flip them. So why am I showing you this? Now, you're going to wish it was this, but it's not. This is not flipping F. This is not putting it over 1 and writing him down. This is not a reciprocal. Now it's in function notation, the little -1 power, which is not a -1 power. And if you say it, I'm going to continually not embarrass you, but at least correct you. You're going to need to say the word F inverse of X. Because there's an idea of an inverse in math that I know you guys have talked about before. That says if you want to find an inverse function, you switch the x and y's and solve for y. But when you solve for that y, it's no longer y equals f of x, it's y equals f inverse of x, because you have switched everything. When you switch the x's and y's, all the x's of the original have now become the y's of the inverse. And all the y's of the original have now become all the x's of the inverse. Now, there are ways that this affects graphs. They reflect across the identity function, across the y equals x line. There are ways this affects points. All of the ordered pairs of this one are on the other one, but switched. There are ways this affects functions in that, well, everything's going to be backwards. What was times is now divided, and what was added is now subtracted. What was square rooted is now squared, or vice versa. However, the order is very important. The goal of every inverse function is to be able to, ready? Undo the other. A function and its inverse and its function, they are the undoing of each other. Oh, this could be interesting. All right, well, homework is due on Tuesday. But you switched x and y and solved for y before. I think you can start homework this weekend. Right? Go learn how to play Sudoku. Sudoku 24/7. They have tons of them. I mean, your homework. I mean, do both.